Good day, everyone. Today, we are going to discuss the algebra of functions. If we let f and g be two real-valued functions, then we define the sum, the difference, the product, and the quotient of f and g as follows. The sum f plus g of x equals f of x plus g of x. The difference f minus g of x is equal to f of x minus g of x. The product f times g of x is equal to f of x times g of x, and the quotient f over g of x is equal to f of x over g of x, where g of x is not equal to 0. Here, x must be necessarily be chosen in such a way that the two functions f of x and g of x are defined. Hence, we define the domains of the sum, the difference, and the product to be the intersection of the domains of f and g. Finally, the domain of the quotient f over g is equal to the intersection of the domain of f and the domain of g minus the set of all x such that g of x equals 0. Let's have an example. Given the functions f of x equals 2 over x plus 1 and g of x equals 1 over x minus 1, with the domain of f equals the set of real numbers minus the set containing -1, and the domain of g equals the set of real numbers except 1, find f plus g, f minus g, f times g, f over g, and their respective domains. To solve this, let us start by applying the definition. So for f plus g of x, we have f of x plus g of x. According to the given, this is simply 2 over x plus 1 plus 1 over x minus 1. Notice that this is addition between two rational expressions. So what we do is to get the least common denominator. In this case, we have x plus 1 times x minus 1. Okay? In the numerator, we would have 2 times the quantity x minus 1 plus the quantity x plus 1. This may be simplified into 2 times x equals 2x, and 2 times -1 equals -2, plus x plus 1 all over the quantity x plus 1 times the quantity x minus 1. Finally, we will have 2x plus x, which is 3x, -2 plus 1 equals -1, all over the quantity x plus 1 times the quantity x minus 1 as our answer. Okay? For the difference, we have f minus g of x equals f of x minus g of x. Substituting the given, we will have 2 over x plus 1 minus 1 over x minus 1. Okay? This would give us 2 times the quantity x minus 1 minus the quantity x plus 1 all over the quantity x plus 1 times the quantity x minus 1. By distributive property, we will have 2x minus 2 minus x minus 1 all over the quantity x plus 1 times the quantity x minus 1. Combining like terms in the numerator, we will have 2x minus x, which is x, minus 3 all over the quantity x plus 1 times the quantity x minus 1. This is our difference. Okay, for the product, we know that f times g of x is simply f of x times g of x. Okay, which is the quantity 2 over x plus 1 times the quantity 1 over x minus 1, which gives us 2 over the quantity x plus 1 times the quantity x minus 1. Okay? Alright? Finally, we have f over g of x, which is by definition f of x over g of x. This will give us 2 over x plus 1 all over 1 over x minus 1. Okay? This is 2 over x plus 1 times the reciprocal of the denominator, which is x minus 1 over 1, giving us the result 2 times the quantity x minus 1 all over x plus 1. Okay, so we have now obtained the sum, the difference, the product, and the quotient of f and g. For the domains, we only need to apply the definition. So notice that we have the domain of f plus g, which is equal to the domain of f minus g, and the domain of f times g is equal to the intersection of the domains of f and g. Okay, since the domain of f is the set of real numbers except for -1, and the domain of g is the set of real numbers except 1, then the intersection of these two sets would give us the set of real numbers except for 1 and -1. Okay? For the quotient, the domain is the intersection of the domains of f and g, which in this case is equal to the set of real numbers except for 1 and -1 minus the set of all x such that g of x, which is 1 over x minus 1, is equal to 0. However, notice that no value of x would satisfy this equation here. Thus, this is just the set of real numbers minus the set containing 1 and -1 minus the empty set. Moreover, we have the set of real numbers except for 1 and -1 as the domain of the quotient f over g.